Hi there, welcome back. Welcome to video number 2 in the restoration series for the Philips B7X14A. This guy's fighting me. This one's fighting me every step of the way. From, I don't want to give too much away, that's what the video's for, but from blown up tubes to switches that go ping in the night, springs that I can't find. Anyway, this thing is sort of giving me a real typical Philips runaround. Should be expected. I don't know why I'm surprised, but it's a massive radio. It's actually quite fun to work with. If you don't have problems like this, you learn nothing. So I have to look at it as a learning experience and just, grit my teeth and bear it and show you the result. But enough complaining for now. I've got to show you what I've done. This is at the end of the sections that I've done. As you can see, it's lying around here. So let me show you what happened. And I hope it's interesting enough to keep you around. Hope you enjoy it. I've actually, since the first section, become aware that these transformers must be special because the speakers are special. The speakers are 800 ohm speakers. They're not the usual 5, 6, 7, 8 ohms. So these transformers are crucial because if there's something wrong with them, I've got a serious problem. I know these capacitors have to be swapped out. That doesn't worry me, but I need to test these guys. And the best way to do that, without powering up the radio at all, I'll show you what I'm going to do. If we look at the schematic over here, we want to test this transformer. And what I'm going to do is I'm going to connect test speakers on here. I'm not actually going to connect them to the 800 ohm speakers. I'm going to connect test speakers. That's not a problem. And this will be connected to the secondary of the transformer. The primary, I need to feed in a signal. And what I'm going to do is I'm going to connect the signal generator to pin 7 of the tube, which is easily identifiable without a tube in there. So I'm going to feed a signal in here, an audio tone between there and ground, and that should activate across the primary, and the secondary should get the induced audio and we should be able to hear it. That's the plan anyway. So I've got my 2 speakers connected across the 2 outputs over here, and I'm going to feed a, make it 1 kilohertz, stay standard, about 1 volt RMS. We'll see how much we need. Get that out of there. And now I'm going to connect this to pin 7, which is the anode of the tube socket. Yes, I can hear it. Let me make it stronger. So 5 volts on there, 5 volts on the signal generator. That's one side. What about the other one? Yes, beautiful. Both of them are working. That's fantastic. I know now that this transformer is fine, as is this one down here. Now what I'm going to do is I'm going to start at this end and work backwards. I'm going to check what this capacitor is, make sure that that's replaced. This capacitor is one of those big tar covered ones on the output transformer. Get rid of that. I already determined that this resistor is fine. Then I'm going to go further back and do my usual thing. You know, check from cathode to ground. What are we supposed to get? I'm following the line up here. These 2 cathodes are tied together. I'm supposed to have 82 ohms to ground. I'm going to replace that capacitor. That's the cathode bypass cap. And I'll be replacing that there as well. And then we go back. Just keep going back. Check this resistor. Check those values over there. Check these capacitors. I want to go through this entire audio section, okay? I may even just stop here and feed a signal in here, but I'd have to apply power on there. I don't want to do that. Well, I could do that. This is the all-important cap that takes your signal from the anode of the preamp or the driver tube. That's supposed to be at 94 volts, as you can see there. It takes that signal into there, which then goes and drives your output tube, your power tube. If that thing is leaking voltage, right, it's supposed to pass AC, not DC. If it's leaking, it takes some of that DC and loads it off onto the side. And that means this voltage rises. If this voltage rises, the voltage there rises. And if the voltage there rises, it annuls or cancels out the biasing that this cathode bias is doing, and these tubes can run away with themselves. They can overheat, they can burn out, they can blow up your output transformers. That's what I'll be doing. I'll be going As a first stage, I'm going to go back to here and see what we've got. These things over here are just tone shaping. Let's see what we've got. This is 11, this is 10. What is that switch? What actually happens here? You've got your audio coming in here. There's a reference to ground, that's fine. And then there's a resistor to here. That's a voltage divider between there and ground. We have 450. What is this? This is a strange one. 450/50. Is this a fixed resistor? I'm not sure. But I can check that. And then we've got this thing coming out here. And there's this switch. So if this switch is closed, as it is here, then the signal from there leaks through to here, to this resistor, this capacitor. So some of your high frequencies get leaked off to here. If either one of these, either that one or that one, is activated, so if this is over there, then this point does not reach this capacitor, so there's no high frequency leaking to ground. And if this switch is over there, same story. It might come through there, but it doesn't leak to ground. Now, what is switch 10 and 11? Well, switch 10 and 11 is some sort of tone. Can't remember which ones these are, but it's tone, tone. We've got our mono, stereo. This is reverb, and tone is tone, tone. It'll be, I'm not sure. I can't remember what it said on the front of the radio, but that's what I'll be doing next. While we were at it, I just realized I was talking about rare output transformers, but these speakers are pretty rare too. So I'm just going to test them quickly. I put a 1 volt, 1 kilohertz signal, 1 volt RMS. Yeah, that one's good. Let's try this one here. Yep, they're both good. So both our speakers and the output transformers are fine. I'm pretty happy with that. So I've gone a little bit further and I've done some of the audio section. Let me show you. What have I done here? Well, I've replaced those capacitors and they came out quite well. I used two. These were 2.2 nanofarads. I used 2 by 4.7s in series because I needed to get a high voltage. These were 1300 volts capacitors. It's across the transformer, so you need to make sure you got a good voltage rating. And those were put in. This section's all been cleaned up. The actual wiring for the two speakers is all cleaned up and ready for testing over here. So that was done. No surprises. So here we are. This one was replaced, and so was that one down here. All these connections were checked. I can mark the speaker as green because I've tested it. And what else did I do? Then I went on to this section over here, and I followed this cathode circuit. This resistor is perfectly fine. I replaced that with 147 in parallel because I didn't have the appropriate 150 or 160 microfarad capacitor. And here it is down here. Put that in heat shrink because I like the cleaner look. And so that's appropriately marked as being replaced. I also found that this resistor here, the one that comes from the cathode and acts as a power supply to the reverb driver, that was also way out of spec. And by the way, as many of you pointed out, this was not working the way I described it. Well, I made a very convincing description on how this thing modulated the cathode, and I forgot one very important point. That is that this capacitor here would make my argument completely moot. So that's not how it works. This is just a power supply for the circuit, and the signal actually modulates through here. So this probably should show you that someone who's convincing is not necessarily right, like I wasn't. Anyway, I went on and checked this part of the circuit, and this is important because this is the part that really drives that tube. And I was actually quite surprised by two things here. One is this capacitor here was perfectly fine. It's a different type of capacitor, and I took it out of circuit. I tested it. It's damn close in value, slightly lower, and also there's absolutely no leakage on there. I tested that with my capacitance leakage tester. Same applies to the one in the bottom. And then we got to here and I stopped. And the reason is I needed to do this section over here. You see that I've got those two on both sides that go to those tone switches. And that tone, as I've determined, is fidelità and parola, whatever that means. It's probably sort of intimate and orchestra or something. It's just basically, it determines the amount of high frequencies that get cut off by this circuit over here. And I went looking for this, and unfortunately, I found a problem. But before I show you this problem, which I'm going to have to work on right now, I want to show you what else I discovered, which left me quite sad. You may recall there were two wires hanging out here, and I didn't know what they were. Well, unfortunately, I found out what they are. They go down there. There are two connection points down here. This is the back of the faceplate. And as some of you mentioned, this is one of those luminescent ones. You can just sort of see that it is kind of strange. It's got some writing here, Phillips, whatever. I'll have to take it out and check. But the fact that the thing is disconnected probably tells us that there's something wrong with it, that it's probably not working, which is a shame because I believe revitalizing these things is, I believe it's impossible. But some of you actually mentioned it. I hadn't looked closely enough and I hadn't realized this is what this thing's got. So that's another challenge that I'm going to have to face. But let me show you what's with these switches. These are the tone switches. You remember mono, stereo, what is that third one? Reverb, and then fidelità and parola. Well, there are two of them that are broken. These things were snapped off. Now they go in here, but I'm going to have to stick them on here somewhere. These things are still operating up and down. I can still move it, but I'm going to have to somehow stick this to the bottom in such a way that this thing still operates and that it still clicks onto this little back thing here that I try not to lose the springs. This came off here. There's two springs on there. This is what really pushes it down. When you activate the switch, it lifts and grabs, lifts and grabs. You see that? It's got the same thing on here. Now there's one missing here, this one, and that one. So I'm going to have to repair that, and I'm not sure how I'm going to glue that in such a way that it actually stays in place. Also, I can't let whatever gluing I do affect these little bumps on here. These bumps on here, that there is what clips onto the back of these things or the top so that it holds in. So that's what I'm going to have to do, and then I'll be able to check the workings of that switching that we have in the just before the power tubes. Let me think about it and get back to you. Well, I thought about it a lot, and I decided the best way would be to try and glue it in place. So I did that, left it overnight to dry, and then this morning I found that the one side is working fine and that the other one didn't do so well. It cracked again because I was trying to put the spring in the back of those switches and I put too much force laterally, and obviously this thing has got pretty poor shearing power and it broke. So I have to redo that. But in the meantime, I wanted to check the connections to those switches, so I decided to take this off. I'd done a bit of cleaning over the top so far, but I needed to clean the back as well. So again, back to cleaning. This thing comes off quite easily. You just take two screws off the side there and it all just comes out. One of the things that comes out as well is a little plate at the back. It's clipped. It's actually connected through the bottom with the same screws that connects the switch assembly. This thing is what guides that, what is it? It's like an indicator for stereo, left and right channel. So once this is out, you can take the opportunity to just clean it up. It's again got that tar sheen from smoker's environment. What I use is that natural bristle brush. It does give it just the right amount of friction. Isopropyl alcohol. Just scrub away and you start seeing the paint coming through, or the color coming through. And then I use this DIY system to clean that up. That's got some cotton wool. And just keep going. It's boring, it's slow, but it's got to be done. This makeshift tool is something I made out of one of my favorite tools, which is a chopstick. You split it down the middle, and you can use those makeup remover towels or something similar. Fit that in, DIY spring, and you got yourself a perfect cleaning tool. Yep, Chinese chopsticks are great stuff. And now it's just a question of putting it all back. And of course, it has to be complicated by the fact that you have to hold that little screen thing at the bottom as well at the same time. But again, patience, perseverance, and be careful. If those screws fall inside there, when you put them on, you're going to have a problem. By the way it's being put up there is the wrong way. Those go at the back, as I found out later. And we are done. All I need to do is glue that the broken one, the one that re-broke, back on again, and we're good. And I'm just clipping this spring, which is what drives that indicator left and right. Here we go, left and right, and it does need some cleaning, so that's what I'll do next. I've put in the two EL84s on there because I want to check that they're okay. Now, the reason I can do this, or I believe I can do this, is because I've checked this entire section here. Everything seems to be okay, and I've found nothing wrong with it. I've done the corrections or checking of the switches, as I've just shown you. I did all the cleaning on both sides. And now if I put in the power tubes, I should be able to inject a signal here, and it should come out of the speakers. Now, I need to use the actual speakers from the radio because of their impedance. They're 800 ohms, so I can't really use my test speakers. I don't want to try that, and I'm going to be setting that up. Okay, so I should have done all this as well, okay? There may be a short here somewhere, but I really want to make sure that the power stage is working, okay? Call me impatient, I am. So that's what I'm going to do. I'm going to feed it in here. I suppose I could put in the 12AX7 and feed it in here. That might actually be a better idea. If I feed it in here, and then I feed it in... No. Let me do these two tubes at a time. First these two. So that's what I'm going to do next. So the tubes are in, just as they were before. And I've got the dim bulb in line here. I've got one light bulb only, 40 watts only, and I'm going to switch it on. I know this is working because I have, in the meantime, put the dial lamp on there, a new dial lamp, so that's working. So I'm just checking the current. It's only 90 milliamps at the moment. I can see the heaters on that coming up, which is good. Oh dear. This one is going a bit bonky. Let me put off the light. I think you can see that. This one is kaput. It looks nice, it's purple, but it's definitely kaput, and the light bulb is glowing. See if you can see that. Can you see that purple light over there? That one's definitely kaput. And look at the dim bulb. This thing is really glowing. Okay, time to put it off. And I'm going to swap out that tube for another one that I've got here. And then we'll try again. I've put in a different EL84 in there. And let me see if I can see the heat. Yeah, I can see the heaters. Right, I can see the heaters on both. And the current is at 90. Let's give it a little bit more time. Yeah, it's sort of coming up to normal. I think I'm ready to try the... I'm ready to try putting in some audio. Let me set up the speakers. I'm getting some sort of buzz coming through, but what I've got is I've got 10 millivolts coming out of there. I'm not sure how much I need. comes in here through a capacitor, 100 nanofarads, and then I've connected this to those 2 points that I mentioned on both sides. If I put that on, I can hear it. Let me give it a bit more amplitude. 30 millivolts going in. So that's working, but the buzz worries me. Let me try something here. I'm removing the one. Oh, okay. One side isn't working. See that? That one's working perfectly. This one isn't. Now, which one is this one? This one goes to that tube that I've not replaced. So I'm going to replace that and see what we get. I did not replace the tube. What I did do is I swapped the tubes that I had in there. So let's see if we hear it now. Not really. And the old one works fine. So the problem is not in the tube. Yeah, the one side has got the effect of the reverb tank going to it and taken from it. So maybe that's the answer. I'll have to have a quick look and see what could explain this this difference. Okay, I've got both sides working now. This was actually a problem with a speaker connection in the chassis there, nothing to do with the actual stage. So there's one side, there's the other side, and obviously if I touch that, that is brilliant. That's brilliant. Let me switch this off. So what have we determined? Well, what we've actually discovered is that all this that I've painted up and checked is working, because I'm feeding the signal in here and it's going through there, getting to the speaker. Likewise, when I feed the signal in here, it's going through all that and also getting to the speaker. So, okay, so the power stage itself is working from that capacitor onwards. So, okay, that's some progress. There's still quite a bit to do. This thing's been a bit daunting because of some of the little things that I've been discovering along the way that need attention, like the switch that was broken and so forth. But what I'm going to do next is focus on this over here. And this over here is interesting in that it works slightly differently depending on whether you're using stereo or mono, and we have to study that. And the way to do that is, actually it does more than that. It has stereo, mono, and it also has the reverb circuit that comes in and sort of throws that for a loop as well. So I'm going to do a bit of a study of this and then carry on. I've continued going back on this section, checking all these circuits around here. This is the preamp section, but more importantly, this has got the feedback section as well. It's not unusual. With Philips, it's just done slightly differently. Now, the way they do it is they take feedback from the output, from the speaker, comes back here, and here you've got this rather convoluted circuit, which is nothing more than some sort of filter. But if we look at it, this is what we got. We've got feedback coming in here. Now, why would the feedback come back? Usually it's to add or subtract from your main volume control, from your main signal line. So if we look at this here, we've got the triode here being fed into pin 2, as usual, the grid. And if we follow this through, we've got the reverb circuit, but all it does here, it's not activated at the moment. So we go back through here, this signal comes to here, it dies there, but it comes to the pot wiper. Now that's perfectly normal, that's what we want. That's the start of the entire preamp and power amp signal. But what is fed to the wiper? Well, before we look at what is fed to the wiper, which is from here, let's look at what's hanging on from the wiper or from the pot. What are all these things hanging around here for? Well, let's look at it. First of all, the pot doesn't go straight to ground. It goes to 100 ohm resistor. And this is just a convenient spot to add or subtract signal from. You see, if you've got this pot on ground, then everything that comes out here is relative to ground. So it's an absolute relative signal, right? But if this thing is floating up and down, and you're floating up and down, it means that the signal getting into the triode is reliant on what's coming in here, on the position of the wiper, which is the volume level you want, but also what the hell's going on here? You know, what signals are floating around here? This is not an absolute ground. And the reason is this signal comes back from here and it joins up through all this mess to the feedback signal from your speaker, okay? So your speaker signal comes along here. It's got a resistor here and a capacitor here. So this will affect high frequencies differently to low frequencies. If you can imagine that high frequencies and low frequencies get through a 27K resistor. No problem, right? But they do get attenuated. However, if you are lucky enough to be a higher frequency, then you can bypass that resistor. You skip around it. You know, it's an easier path, which means that the signal that is here is more high frequency rich than the one that's coming through just through the resistor. So that gets to here. Then you get another resistor, another capacitor here, which cuts off some of the low frequencies again. But there's an alternative path through here. So this gets very messed up. And we can see basically what they're trying to do. They are shaping the amount or the frequencies that get back to here to subtract from your signal going to the preamp. So the feedback is negative feedback. It has to be, or it'll oscillate like crazy, but it is frequency dependent. And it's a section of the frequencies that you select. But more than that, you can actually taper them even more. And that is because you've got this path here. And this path is really an escape path for whatever frequencies can get through this capacitor. Now, what frequencies can get through a capacitor? Higher frequencies. How high? We don't know. We'd have to do a lot of calculations or simulations to find out. But high frequencies can escape through this resistor before going back there. So if they don't go there, they won't subtract from there. So those frequencies will be allowed to come through unhindered because the feedback, the signal that says, whoa, don't send me anymore, is escaping. And it's escaping to ground. Under what conditions? Well, if you have FM selected, this switch goes to there. So those frequencies don't escape to ground. If you have pickup selected, boom, that goes to there. So those don't escape to ground. So whatever feedback you are allowing through here, you are changing it, you are altering it for pickup and FM. What does that mean? Well, with pickup and FM, those are the two signals that you expect to have better fidelity on, okay? You don't expect much fidelity, much quality audio from your AM bands, but you do from FM, and you certainly do from your pickup. So whatever this is doing to the feedback, and quite honestly, I'd have to simulate this to see, you know, and I don't really want to. I've done this before. It just is a subtraction or an addition of certain frequencies in relation to others that will be allowed to be seen by the wiper of the pot. That's all you've got to remember. This would determine which frequencies are deducted from your main signal in order to be seen by the wiper of the pot, in order to be amplified by the triode, in order to be amplified by the power tube, and then come out your speaker and come back and say what it's done, because that's the feedback path, okay? But whatever you're doing there, you don't want to mess it up, some of it up, with the pickup and the FM. And that's why these guys are there. And this entire circuit chain is perfectly fine. I changed absolutely nothing. I checked everything. This is the one channel. If we look at the other channel, exactly the same thing applies. These are exactly the same. Coming back, going through that signal shaping, tone shaping, and then it goes into the bottom of the pot. There's one more thing here, and that is this over here, this resistor capacitor. It's also on the other one. It's from a section of the pot to the bottom of the pot. And this is for a pseudo loudness. What happens is basically at low volumes, your bass is boosted. It's like a loudness control, and it gives you that rich sound even at low volumes. This is very common with these radios. They have a tap on part of the volume control. So no mystery there. The only things that add on to this side are the sort of the takeoff from for the reverb section, but I'm not worried about that for now. I'm still on the preamp, and I'm really interested in what is coming in. Now, as I said, we've got to the point where we know what's coming into the top of the volume pots, but where are they going to? Well, they're actually going to a balance pot. Now the balance spot is this guy over here. And the balance spot has to do with which side, which channel, left or right, you want your signal to go to. And the reason you do that is because you've got a stereo signal coming in from your pickup, or if it's a mono signal, it's going to both, but you want to push it more to the one side than the other. So you've got a balance spot. And the balance spot works, well, basically like this. You've got a situation where the signal is coming in here. It's got to come in here. Comes in here, goes to the top of the balance spot, but there's a wiper here which cuts off. In other words, you can cut off that. If you've got this on as it is now, and 10 and 11 are those tone, the hi-fi and, what is it, hi-fi and speech, this gets cut off. So effectively, you could cut off the entire thing. Whatever you do on this side, it'll do the opposite on the other side. Okay, so you are sending the signal more to here than to the top of the other volume pot, and vice versa, depending on how you set this. All I've done is, what I'm doing is just checking these connections, and I want to make sure that coming in here, and 2, if you recall, is pickup, the pickup button. So that is selecting between pickup and radio. Actually, I'm not even sure that it's doing that yet, because there's still this question of the reverb that gets blended in here. But anyway, that signal there is really the input, the real input to this side of the amplifier, this section. And if we go down here, we've got a similar situation. This here is the real input to this side of the amplifier. Now, this one goes to, if we follow this back, just following the signal, to 12. 12 is stereo. So if it's like this, it's on mono. 2 is pickup. If it's like this, it's on radio. So that would be receiving a signal from there. And that same signal will be going to here, and hopefully, yep, to there. Okay, so if you've got radio, that signal is just going to both sides the same way. So there's no difference between the two channels. Brilliant. But there's a lot of switching going on. And I just wanted to make sure that the audio section, the components, were fine. And I've just got to quickly check this, and then I think I'm ready to test the entire audio by inserting a signal in here. With, obviously, this tube in place, which has 2 sections, that section and that section. Okay, let's get going. This bugger is fighting me. It's fighting me all the way. And, okay. I've done all the checking. I've done all the confirming that it goes back to where it's supposed to with all the switching and all that. Basically, I want to look at the pickup input, make sure that I can feed a pickup signal in here, or an audio signal into the pickup, and that'll come out both speakers. Well, it's not working that way. One side gets through, one side doesn't, which is strange because when I check continuity, it all works. So I decided to step back and go one step further forward in the circuit. In other words, not be as optimistic as I was. And what I've done is I've fed the signal into the top of the 2 volume pots. That is it over there. The same signal is going to the 2 volume pots. I switch it on. I've got the ECC83 in there. And I want to see what happens. Give it a bit of time. I've got this connected to the actual speakers again because impedance reasons. So there we go. And there's the volume control. A little bit of scratching is still left there. I've cleaned that a couple of times, but you need to do it again. So something is wrong between where the pickup input is over here on the DIN connector and the top of the volume pot. Shouldn't be difficult. It's just driving me nuts, and I'll show you why in a second. But the point is, these signals are getting through. It means that the 12AX7, the ECC83, is perfectly fine, which is progress, I guess. I really would have preferred to have got this whole audio section working. Let me turn that off because it's annoying, because I want to show you something. this switching system here is giving me hell. I had two broken, two broken poles there. That one there was broken, and that one there was broken. I managed to glue this one, and it seems to be holding, but this one broke again. So I have to sort that out. And in doing so, just so you know, this is hi-fi speech, reverb, stereo mono, okay? And in doing so, one of those little springs, or both of them, jumped up when I was taking this lid off, and I don't know where it is. One of them I found, the other one I haven't, and what worries me is that it fell into there. So I need to do some searching. I need to figure out how I'm going to fix that. I've cleaned all these guys. They came out beautifully. They really came out well, but one of them is broken. And gluing that is not that easy. You can't just use super glue because it won't hold. And you can't really get in there because there's no space. This thing has to move backwards and forwards, so you can't really take up the shaft. There's a small hole there. I'll have to figure it out. I will figure it out. But in the meantime, I think I'm going to be looking for a very small spring in a very confusing chassis. My concern, of course, is that it's somewhere that'll create a short circuit. Even the testing that I did with the dim bulb on maximum restriction, just in case. It's here somewhere, but it's a little black spring and it's small. It's that guy over there, one of them, and I just don't want to take any chances. So I'm going to break for now and get back to some of the grunge work, finding out why things don't work. So for now, that'll be the video, and I want to thank you for your company. Hope you've enjoyed that. I've certainly learned a lot. I hope you've learned some. There is one more thing, by the way, one more thing. I mentioned that faceplate, that luminescent one. I took it out. This is the condition it's in. If any of you know how to restore this thing, how to bring it back to life, I don't. I'm thinking of perhaps just getting a light diffuser, putting some LEDs on the side. It's got a pretty nice connection thing here, so you can, add LEDs on the side, get the LEDs to diffuse light. Maybe use a piece of old laptop screen, the diffuser they use on there, because I don't think I'm going to be able to rejuvenate this guy. Anyway, your comments are appreciated, and maybe someone has, well, I'm sure a lot of you have better information on this than I do, but maybe someone will come up with a good idea. So I'm going to sign off for now. Hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now, and stay safe.